All right, today we're going to be talking about how to graph quadratics from vertex form and the different transformations that occur in vertex form. And we're going to be just looking at, first of all, standard form, remember, is that y equals ax squared plus bx plus c. Vertex form is going to be a little different. And we've talked about vertex form in the past. We've talked about it back in Unit 1 when we were first talking about transformations. And that is, remember, y equals a parentheses x minus h close parentheses squared plus k. All right, and that h and that k can shift where our vertex is found. All right, so we're going to graph the parent function and the given function, state the transformations that occur. So the parent function is y equals x squared. All right, so x squared, we have 0, 0 is our vertex. Then we have points at 1, 1 and negative 1, 1. We have points at 2, 4 and negative 2, 4. And then 3, 9. I don't know if it goes up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And negative 3, 9. So that is our parent function there in the black outline. And then our vertex form, the way we graph from that is we're going to make an XY chart. We're going to put our vertex in the middle. Our vertex is going to be found at, so x minus 2, so it's going to be found at 2, and then plus 3, so 2, 3. All right, so then we're going to find two x numbers to the left of 2, so 1 and 0, and 2 to the right, so 3 and 4, and just run those through the function. 0 minus 2 is negative 2, negative 2 squared is 4, 4 plus 3 is 7, 1, now we'll do 1 for our x, 1 minus 2 is negative 1, negative 1 squared is 1, 1 plus 3 is 4, and then of course those mirror, so we've got points at 0, 7, we got points at 1, 4, 3. Actually, let me, instead of doing those in black, I'm going to do those in red so we can see those a little better. Two, 3, 3, 4, and 4, 7. All right, and so that red parabola, you can see it opens the same width. We haven't affected the steepness of the opening. All we've done is move the vertex 2 units to the right and 3 units up. So we had a vertical translation. Up 3 in horizontal translation. I'm going to write 2 units. Okay. So again, we are going to graph the parent function here. So go ahead and do that. In black. The black is the parent function here. And this time, our a is going to be 1/2. And our vertex is going to be 0, negative 3. Now, with our a being 1/2, what I would suggest is to find numbers that are divisible by 2 for our x's. So I do negative 2 and negative 4, and then positive 2 and positive 4. You'll see why here in a second. If we were to do an odd number, we would end up with some fractions, and I know Some of you really get freaked out about fractions, so we're not going to do that today. Don't want to freak anybody out. So let's just fill out our table. All right, so negative 2, or so, we'll start with negative 4. Negative 4 squared is 16. Half of 16 is 8, and 8 minus 3 is 5. So then we'll run negative 2 through the function. Negative 2 squared is 4. Half of 4 is 2, and 2 minus 3 is negative 1. And then those would mirror. So you can place, let's see, negative 4, 5. So 1, 2, 3, 4, up 5. And then negative 2, 1. 0, negative 3. 2, negative 1. Ah, I did that one backwards. And then 4, 5. Let's see, 1, 2, 3, 4, and up 5. Okay, so the parabola of that one looks like that. And you can see that it has been vertically compressed, vertical compression, by 1/2, and then vertical shift, or vertical translation, down 3. And that's the transformations that have occurred there. All right. So again, parent function. So we can go ahead and draw that on there. Okay, that's our parent function. Now this one, we make our XY table. Our vertex goes in the middle, so our vertex can be found with our H and our K. Our H is going to be the opposite of that, so it's going to be negative 1. Our K is what it is, so negative 1, negative 3 is our vertex. So then I'm going to find points to the left and to the right. 2 points to the left, so negative 2 and negative 3, and 2 points to the right, 0 and 1. Then run those through. All right, so negative 3 plus 1 is negative 2. Negative 2 squared is positive 4. 4 times negative 2 is negative 8, and negative 8 minus 3 is negative 11. Then we've got negative 2 here. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 times negative 2 is negative 2, and negative 2 minus 3 is negative 5. And then, of course, we can mirror that. So we will go ahead and plot those points, negative 3, negative 11. This only goes down to 9, so we got to go off just a little bit. Negative 2, 5. Sorry, negative 2, negative 5. Negative 1, negative 3. 0, negative 5. And 1, negative 11. Okay, so lots of transformations that have happened here. Okay, we have let's see, we have a reflection across the x-axis. And we have that because it is a negative, our A is negative. We have a vertical stretch. By a factor of 2. And we have a horizontal translation. left 1. And we have vertical translation. And we went down 3. All right. So what does the A do to the graph? Well, there's two things that A can do to the graph. First is a vertical stretch or compression. It can also, if the A is negative, reflect across the x-axis. What does the H do? The H moves vertex, moves left to right, moves vertex left to right, left or right, I should say. And the K moves the vertex up or down. All right. The transformation from y equals x squared represented by g. Okay, so g has moved the vertex 2 units to the right and 2 units down. So if our vertex was at 0, 0, our vertex is now at 2, negative 2. If we had points at 1, 1, and negative 1, 1, we now have points at, like that, at negative, or 1, negative 1, and 3, negative 1. We had points at 2, 2. So we just need to move those 2 to the right and 2 down. No, sorry, we had points at 2, 4. Sorry, 2, 4. And negative 2, 4. Okay. So this is what our new parabola, oh, I don't want to make that in red. Let's see, we would have had points at 3, 9, so we'll now have that at 5, 7. And we had points at negative 3, 9, so now it's going to be at negative 1, 7. So everything just moves 2 to the right and 2 down. So we just shift everything. So that's one way to do that without making a table. We can actually just adjust everything if we just can remember where those parent function points are. All right. Now, whenever our A is not 1, it's probably easiest just to make the table. It's going to be so much easier just to make a table of x, y's, put your vertex in the middle. In this case, it's going to be 2, 0. And then pick 2 numbers to the left, 2 numbers to the right. Since our A has a denominator of 2, we're going to go by 2's. And then we run those numbers through the function. So negative 1 minus 2 is negative 3. Negative 3 squared is 9. Why did I do that? That should have been negative 2. Negative 2. That's better. I don't know why I picked negative 1 there. So negative 2 minus 2 is negative 4. Negative 4 squared is 16. Negative 1/2 times 16 is negative 8. Then 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times negative 1/2 is negative 2. And then 4 minus 2 is 2. 2 squared is 4. 4 times negative 1/2 is negative 2. 6 minus 2 is 4. 4 squared is 16. Negative 1/2 times 16 is negative 8. So, turns out we didn't even need to do that. All we had to do is describe the transformations. So the transformations, reflection across the x-axis, and then we move 2 units right. And we also had vertical compression. All right, so then for B, sorry about that, that was silly. For B, we have to talk about our transformations. Let's see, vertical stretch by a factor of 4. And a vertical shift, or vertical translation, I should say. Up 1. Okay, example 6. Let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. Write a rule for G and identify the vertex. Okay, rule for G is going to be G of x equals vertical stretch by a factor of 2 and a reflection in the x-axis. So that means it's going to be negative 2, parentheses, x. Let's see, is there any horizontal shift? Nope, no horizontal shift or translation. So we actually don't need the parentheses. So x squared, and then we have a translation 3 units down, so minus 3. And the vertex then is going to be at 0, comma, negative 3. Now, the last part of this is converting from vertex form into standard form. Now, there's no like quick and easy way of doing it. What we've got to do, first of all, is we need to expand this x plus 2 squared. And we're going to write that out as like that. All right, then I'm going to distribute that negative 3. Negative 3x minus 6. X plus 2 minus 4. Then I'm going to do FOIL, which means I'm going to distribute the negative 3x and the negative 6 to the x and the 2. So negative 3x times x is negative 3x squared. Negative 3x times 2 is negative 6x. Then I have negative 6 times x, so that's negative 6x. And negative 6 times 2 is going to be negative 12. So then I need to combine all these like terms. So I have negative 3x squared minus 12x minus 16. And that is how I would convert that into standard form. Standard form, I have my A is negative 3, my B is negative 12, my C is negative 16. And that's it. All right, if you have any questions, please shoot me an email or a Canvas message, and I'll get back to you as soon as I can. Have a great day.